Welcome to This Explainer. Today, we're diving into something completely fascinating, but honestly, a little bit terrifying. We are demystifying the wild new frontier of cyber threats, looking specifically at the very real, practical vulnerabilities targeting our AI agents today. We're moving way past theory here to look at exactly how the AI assistants we rely on are literally being compromised from the inside out. Okay, let's jump right in.
Let's kick things off with a massive wake-up call. 21,000. That is how many instances of the OpenClaw AI agent were recently found just sitting out there, totally exposed on the open internet. And remember, we aren't just talking about passive databases here. These are active, autonomous entities. They have access to local file systems, shell environments, API credentials, just sitting there waiting for someone to give them instructions.
So how are these agents actually getting compromised? Well, it all comes down to agent skills. Think of a skill less like a basic tool and more like a hyper-detailed onboarding manual written for a new employee. It gives your AI brand new, complex capabilities. But as we're going to see, when you give an agent new skills, you're also handing attackers a shiny new key to the front door.
Trend Micro coined a phrase for this, and it hits the nail right on the head: the lethal trifecta. It is a perfect storm. Your AI agent remembers things across sessions. It has the power to execute commands on your computer, and it's constantly ingesting brand new, untrusted data from the web. You combine those three things, you give attackers the absolute ultimate leverage to manipulate your agent.
Here's our roadmap for today's explainer. 1. The new AI attack surface. 2. The Malicious tool playbook. 3. Weaponizing agent skills. 4. A case study on an OpenClaw compromise. And finally, 5. Why traditional security fails.
All right, Section 1. The new AI attack surface. When trusted workflows become vulnerabilities. You know, the contrast here is pretty wild. Traditional malware is essentially a burglar, right? They're trying to pick the locks or break a window to force their way into your system. But malicious AI tools, we are literally inviting them right through the front door. They aren't exploiting a software bug. They operate exactly within the agent's intended framework. The AI actually selects and executes the malicious tool all on its own because it just inherently assumes the tool ecosystem is safe. Moving right along to Section 2, the Malicious tool playbook, deconstructing the CIA Triad for AI.
If we map out the attack pathway using the Mal tool framework, it starts so innocently. A bad actor uploads a poison tool to a platform. A user inadvertently installs it, probably because the description looked super helpful. Then, the moment the user gives the agent a task, the LLM agent actively selects and runs that malicious tool, bringing the threat straight into the user's secure environment. So the big takeaway here is that these threats hit every pillar of the classic CIA security triad: confidentiality, integrity, and availability. But they are completely adapted for AI. Attackers can silently exfiltrate your API keys, they can poison the agent's database so it starts lying to you, or they can even hijack your GPU compute power to mine crypto, which obviously tanks your agent's availability.
Section 3. Weaponizing agent skills. Exploiting progressive disclosure. Akamai recently mapped out the top threats here, and a lot of it is about exploiting something called progressive disclosure. Basically, to save memory, an agent only loads the skill's metadata at first and loads the actual code later. Attackers exploit this mismatch. They write a perfectly harmless-looking description to trick the agent into selecting it, but they hide the real malicious code in the payload. They also love to abuse implicit trust chains, where the output of one poison skill is automatically fed into another one, spreading the infection through your whole workflow. If you want to know the scale of this issue, brace yourself. A Claw Secure audit of nearly 3,000 widely used agent skills revealed that 41.7% carry substantive security vulnerabilities. Almost a third of those were higher critical severity. This isn't some rare edge case. If you're downloading popular skills for your AI agent today, you are facing a massive supply chain risk.
Let's look at a real-world example in Section 4. Case study: OpenClaw compromised. The reality of persistent threats.
The Cloud Security Alliance dug into this and found a huge architectural flaw in OpenClaw. It systematically mashes together your trusted configuration files with totally untrusted external content. OpenClaw loads your personal identity files into the system prompt, but then the agent goes out and reads random emails and web pages. Because it's all blended into the same context window, the AI literally cannot tell the difference between your core instructions and a hacker's hidden prompt injection. Now, what makes this a real nightmare is the persistence factor. An attacker places hidden instructions in a shared document, your agent reads it, and those instructions basically tell the agent to rewrite its own sol.md and memory.md identity files. The agent thinks it's just updating its memory, so it does it. Now, even if you restart your computer or wipe your chat history, the agent remains permanently compromised. Its very identity has been hijacked.
Okay, let's walk through a zero-click data exfiltration exploit. And I mean 0 clicks. It is terrifyingly simple. First, you ask your agent to summarize a web page. Hidden on that page are instructions telling the agent to grab your passwords and stick them onto the end of a specific URL. The agent then sends you that malicious URL in a Telegram or Discord message. Before you even open the app, the messaging platform automatically pings the URL to generate a little link preview thumbnail. Boom! Your data is instantly sent to the attacker's server, and you didn't even click a thing.
Finally, Section 5. Why traditional security fails. The authorized behavior paradox.
So why aren't our massive, multi-million-dollar corporate security systems catching this? It all comes down to the authorized behavior paradox. Think about it. There is no malware binary here. There's no privilege escalation. The AI agent is executing these malicious instructions using its own authorized credentials. As far as your security software knows, the agent is technically just doing its job perfectly.
So how do we fix this? The Cloud Security Alliance says it's time for a zero-trust posture tailored specifically for AI. We're way past simple hash checks. We need file integrity monitoring for core agent identity files so we actually know if they're being rewritten. We have to treat all external content as inherently untrusted, and we need to establish semantic baselines to catch that subtle, gradual behavioral drift before an agent goes completely rogue.
I want to leave you with a thought to consider. If the AI systems we trust to manage our entire lives, our schedules, our workflows, our emails, can have their very memories rewritten by a simple web page, are its decisions truly its own anymore? Or are you already working for the attacker? Keep that in mind next time you grant an autonomous system access to your life. Thanks for joining me for this explainer, and stay secure out there.